This video is going to have a look at how to figure out ionic equations and then in turn figure out half equations. These are not always possible from an ionic equation, but sometimes they are. These are an extension on balanced equations and word equations. So really they go word equations, balanced equations, ionic equations, half equations in terms of difficulty. So if you really do struggle with word equations and balanced equations, I strongly suggest you go and watch a video on that before you come on to this, because if you can't get the balanced equations, this is going to be very, very difficult. So let's have a look at an example. So this is what we call a displacement reaction, and you don't really need to know the chemistry behind this, but we'll touch on it. But the idea is the magnesium is more reactive than the cobalt, so it's going to go over here. Now, based on this, what it would suggest is that actually the nitrate is more attracted to the magnesium. And we'll have a look at why that's not necessarily the case, but it would get you the mark at GCSE. But the idea being that you should sort of try and get in your head here is magnesium is more reactive. Now, I'm not going to put the state symbols, but the really important bit to notice are the state symbols here. The reason I'm not going to put the state symbols in is just because you can't read them on this board, because it just doesn't come up very clearly, because they have to be quite small. But aqueous means dissolved, so S means solid. So if it's aqueous, that means that all those particles are actually separated. So when we do that, we're going to separate these out, which means I've got cobalt 2 plus, which will be aqueous, plus 2 NO3 minus. I've got 2 because there's a 2 here, so that applies to everything in brackets, plus the magnesium here, which is going to stay solid. All right. On the right hand side, what's happened now is the magnesium is now aqueous. So in that case, I'm going to have Mg2 plus those 2 NO3 minuses plus that solid cobalt, okay, because the cobalt is now solid. Now, the bit that sort of people trip up on here, because this is not an ionic equation yet, this is not worth the marks. All I've done here is separate these two out. What you'll notice is the nitrate is exactly the same on both sides. So what we do is call that a spectator ion. And a spectator ion is like a guy at home watching a football match. He's got no role in the football. He's not actually having an impact on the score, whether he thinks he does or not by shouting at the TV. But he has no impact on the actual reaction. He has no impact on the score. He is just there watching. And that's pretty much what the nitrate does here. They're spectators. They're just watching. So actually, my ionic equation in this is cobalt 2 plus Mg gives me Mg2 plus cobalt. Okay, now, as I said at the start, it looks a little bit like the nitrate is being attracted to the magnesium, and at GCSE you would get away with that. The reality is that's actually not happening, because the nitrate actually has nothing to do with this. So what's actually going on, we're going to have a look at in the next one. So this is my answer for the ionic equation. But let's turn this into a half equation. So this is what I've got. Now, a half equation is where you remove all but one of the elements and you replace it with the others that you have removed with electrons, essentially. So, for example, here, I'm going to start with cobalt. So cobalt 2 plus, and then the arrow, and then cobalt as a solid, right? Now, I'm then going to have to add electrons. And I'm going to add electrons to the more positive side, because electrons are negative. So if I add them to the more positive side, that will balance out the charges. So I'm going to add electrons here. And I'm going to add 2 electrons because there's a 2 plus charge and these are 1 minus. So I need to balance that charge. So I'm going to put a 2 there. On the other side, I'm going to put my magnesium, which is a solid. And I'm going to turn it into a magnesium ion, which is Mg2 plus, which is now aqueous. And again, same thing. I'm going to put my electrons on the more positive side, which is on the right in this case. So what's actually happened here is the more reactive element, which is magnesium, is more is giving up the electrons. So actually the electrons are more attracted to the cobalt. So this becomes very tricky to understand why it's more reactive. But the magnesium is essentially giving up the electrons, and the electrons are going over to the cobalt. Now, we actually use this for another thing because this is used for identifying redox reactions. And a redox reaction is reduction and an oxidation. Reduction being the gain of electrons and oxidation being the loss of electrons. We often refer to this as oil rigs. Oxidation is loss, reduction is gain. So this one has gained electrons. So cobalt in this case has been reduced. Magnesium has lost electrons. So magnesium has been oxidized.